Okay, so here we're going to be talking about one-sided limits and when a limit exists. So here's a function. It's a piecewise function. Let's graph it. So x is less than 0, so that's going to be this half. And then f of x is equal to x plus 1. Well, that looks like it's a slope of 1, y-intercept 1. So it's going to look like that. And then on the right side, it's going to be x minus 2, which is slope of 1, y-intercept negative 2. So like this. And then to show that it's greater than equal to 0 for this part, we're going to put a hole at the top and just a dot, filled in dot there. Okay. Now, if I asked you, what is f of x evaluated at 0? Well, all you have to do is find this right side of the piecewise and figure out which piece is dealing with 0, and that's going to be this piece, because this is when x is greater than or equal to 0. So we're going to use this part, and then we're going to plug in 0 for x. So that's negative 2. Okay, that's fine. But what about if you look at the limit of f of x as x approaches 0? Now, what does that mean? That means, what does well, let's look at it over here. So let's say x is approaching 0, right? But f of x isn't approaching anything. It's approaching, negative 2 down there, but it's also approaching 1. So maybe the answer is negative 2 and 1, right? But we don't do that. So we say that the limit does not exist. Does not exist. And we just use D&E typically because that's just easier to write. And more, to justify it on the test, you would say, well, you just say what I basically just said, that it approaches different things as you approach from different directions. And how we write that is we say the limit of f of x as x approaches 0, and then we put a little positive sign up here. And that means x is approaching 0 from the right. X is a little bit greater than 0. X is something like 0.00001. Okay, so x is coming to 0 from the right. So what's that going to be? Well, x is coming to 0. We're at the right side of the graph. X is coming to 0, 0, 0, 0. And then once we get there, that's our value. So that's going to be negative 2. And then to look at the other part of it, you might have already guessed it, but we write the same thing, but x approaches 0, and we put a negative sign. That just means 0 is a little bit less, or x is a little bit less than 0, and we're approaching 0 from the left, or the negative direction. So we're just going to go to the left, then we're going to go to 0, go to 0, go to 0, go to 0, and that's our value, 1. And let's see, because the limit of f of x as x approaches 0 from the right does not equal the limit of f of x as x approaches from the left. So whenever you have this situation, that means the limit doesn't exist, and that makes sense, right? You can't have a limit here if it's two different things. You can't pick one. So, yeah. And then there's another time that the limit doesn't exist, and that is when, let's pull it up here. Okay, so let's make another let's just make green here is going to be our g of x. So let's make a little inverse function right here. And make this an asymptote. So let's let this be 4. If you want to look at the limit of g of x, this green thing, as x approaches 4, right? You could say infinity, or you could say negative infinity. And, well, there's two okay, so it doesn't exist because infinity doesn't equal negative infinity. So that's one thing, because you can't, it's going in both directions. And even if they were pointing in the same direction, so say green thing looks like that, and it looks more like a 1 over x squared thing. This, you could say it equals infinity, but we just say it doesn't exist because infinity technically doesn't exist. It's more of an idea, an area of large numbers. So even if you have, even both sides are equally approaching infinity, it's not existing.